Hello, welcome to Enots Engineering. I'm Alan. In today's video I'll be doing some modifications to the radius turner. They are to put a post here that I can do a measurement from so I know exactly what radius I'm turning. I've also modified the tool holder and I've carried out some modifications internally. So let's go into the workshop and see how we do. I'm just drilling 2 holes each side of the base plate to put some countersunk screws in to hold the dovetail in position. What I've found is that when you tighten the dovetail in the cross slide with the grub screws on the lathe, it pulls the dovetail down, and because it's not fixed to the block, it pulls the thread down that the bearing is on and tightens up the bearing, so it's difficult to get a nice adjustment. So by putting 2 countersunk screws in there holding the dovetail to the base, I'm hoping that will stop the dovetail pulling down and making the bearing on the top tight. I've just countersunk that hole. Now I'm going to move over to the other side. My 0 position. I've now fitted 2 countersunk M4 screws. On the tool post is put another hole in this end, bore it out so I can have either end. I want to try and put a slot across the middle, and this is experimental, so I don't know whether it will work. You can see how I've held that in that chuck. This jaw's backwards. That's so I've got enough thread in the jaw holding it. These 3 are normal. I've centre drilled it. I'll be trying one of these new cobalt drills. I've reset the bar to drill a hole through the middle. And this central on the chuck, I do that by putting the dial indicator on there, turning the chuck around to get the lowest reading, which is just 1/2 thou. Take it off, turn it round the other side, push it back on, get the lowest reading, which is just 1/2 thou again. So that I know that is central in the chuck. Just finish milling this through, but I've put a slot, it's a 10mm slot, all the way down the piece. I've now started to make the setting pin for the radius cutter. Okay, I've roughed it down into 3 diameters. This will be an 8mm diameter. In this end will be about 11, 12, and this is just clearance, doesn't need any special size. I've roughed it out with this carbide tip, so now I'm going to change to high speed steel to get a better finish. I've finished off the diameters and parted it off, turned it round and put it back in the chuck to face off the end. That's the setting pin. I need to turn some more off this diameter so it fits a tool post. I'm now making a plastic cover that prevents swarf getting into the bearing. 0.974. That's the bearing cover finished. I spent a few hours modifying the radius cutter. The first thing I've done is make this setting gauge, which is basically 8mm at the bottom. This is 9mm clearance, and it goes up to a 12mm diameter. Made that plastic guard just to stop any swarf getting into the bearing. The 8mm fits in there, so it's a good fit. Milled out this slot to miss the setting pin, so this goes in there, that can slide along, the setting pin goes in the middle. You bring the tool to the setting pin, and that is set for a 6mm radius because this is a 12mm diameter. Clamp, tighten up the 3 screws that clamp the adjusting bar to the tool post. Remove the setting pin. Now I can put that in the lathe, see how it cuts. If I need a bigger radius, I can just put some gauge blocks between the setting pin and the tool. If you remember, we put the dovetail piece in the bottom, which I've modified by using 2 countersunk screws to hold it in. That's cured the problem of the bearing tightening up. I'm going to put it about 45 degrees on the base to give it maximum stability on a radius. Just nip the screws up. Before, when I tightened these up, it was pulling the dovetail down inside and locking up the top, so now it's not doing that. Fit the handle, which is off the cutter grinder, just a 8mm bar with a 6mm thread on the end, and that gives us a radius movement. Right, I've just put a piece of aluminium in there. I'm using aluminium, it is easier to cut aluminium, but I've showed you it does cut steel. I made 2 spherical washers. Because this is hopefully set at 6mm, just touch it to the face, lock the carriage, bring it out, turn it round, and start there. Just feed it in till it touch the outside with the cutter, and now I can just finish the final radius. There you can see how good the finish is. That's not been polished with emery, that says it's come off the lathe. There's the 6mm radius gauge, and as you can see, it fits exactly. Well, that's it for today. I hope you enjoyed it. Hope you found the modifications interesting, and we'll see you next time on Enots Engineering.